Hello guys, so I hope you can hear me. Now I would like us to look at chi-square and chi-square values and basically how to calculate them. Now chi-square tests are concerned basically with the individual members of a particular set and are associated with non-parametric sets. And the formula for obtaining chi-squared is given by the summation of the observed frequencies minus the expected frequencies squared, all this divided by the expected frequencies. So let's say, for example, the results obtained from, let's say, a trial are rarely exactly the same as the results predicted by statistical theories. For example, let's say you toss a coin 100 times. It is unlikely that the results will be exactly 50 heads and 50 tails. So let us assume that we say 5 people each toss a coin 100 times, and note the number of, say, heads obtained, tails obtained. Okay, it's so unlikely that the results will be 50-50 for each cases, okay? So most of the time, the expected frequency is that we get 50-50, okay? Because the probability of getting either a head or a tail is a half. Okay, so when we write down, let's say the number of people, so we have a person A, B, C, D, E. We have 5 people, okay, who are tossing a coin. And we write down the expected frequency. So expected frequency, we expect to get 50, okay? Because we have 100 coins. We have 100 coins. So we expect to get 50 heads, 50 tails. So 50-50. But what is the observed? If we carry out this in reality, then we will realize that we will have different observed values. Okay, so we could have here probably, let's say 43, 54, 60, 48, 57. Okay, so we can use the okay, so we can use the chi-squared formula now to get, if we want to, let's say, get the measure of the discrepancy existing between the observed frequencies and the expected frequencies, and that we do using this particular formula. So now that I've written this can be our first example. Determine the chi-square value for the coin tossing data. So let's assume this is the coin tossing data. We have 5 people who are tossing 100 coins, okay? And this is the data. This is the expected frequency. This is the observed frequency. So let's determine the chi-square valued. And this is the formula for getting the chi-squared value. So all we have to do is get, so this is what we're going to have. We're going to have our, so I can have our person here, and then we have the observed values. Then we have the expected values, and then we have a section for observed minus expected, and then we have a section for observed minus expected squared, okay, and then we have a section for observed minus expected squared, all this divided by expected. Okay, let's go. Now, following the table, we have person A, B, C, D, and E. So I'll have A, B, C, D, and E down here. So for person A, we already know the values, so you can just write them again. The observed values. The observed values for person A, we have 43. Expected, we have as 50. Okay, for the next person, 54 and 50, 60, 50, 50, 40, sorry, 48, 50. $48 over here, as the observed, and then 50 as the expected value, and finally 57 and 50. So what is observed minus expected? There's nothing hard here, guys. We are just going straight ahead into subtracting this. So 43 minus 50, that will give us minus 7. This will give us 4. This will give us 10. This will give us minus 2. This will give us 7, okay? And then we square. So squaring this, we have 49. This will give us 16. This will give us 100. This will give us 4. And this will give us 49. Then dividing by the expected value. So in each case, we have 0 minus this. What is the expected value here? 50. So if we divide 49 by 50, we'll get 0.98 here. Dividing this by the expected value, which is 50, 60 divided by 50 will give us 0.32. 100 divided by 50 will give us 2. This 4 divided by 50 will give us 0.08. And then 49 divided by 50 will give us 0.98. Now, in the formula, we need the summation of all this. So we're going to add all this up so that we get the summation. So adding all this up, this is going to give us, so if we add all this up, this is going to give us, so let's see. This and this, if you put this into the calculator, you will get 4.36. And the formula for getting chi-square value was the summation of this. So basically, this is the chi-squared value, and this is the answer, guys. So what you really need to remember here is this formula right here, and note down the observed and expected values of your data. Okay, fine, guys. I would like us to take up another example. Let's take up another example and see how it goes. So example number 2. Example number 2. A dice is rolled 240 times. And the observed and expected frequencies are shown. So here's the data. So we have the face, we have a die, so it has 6 sides. So we have face 1 all the way till 6. So we have face 1, 2, 3, 4, 5, 6. Observed frequency. So we have observed frequency as 49, 35, 32, 46, 49, and 29. And the expected frequency, so it's a dice, so the probability of getting any side is obviously 1/6, and it is rolled 240 times. So we have 40, 40, 40, 40, 40, 40 is what we're expecting. Okay, guys, so using this data here, can you guys get for me the value of chi-squared? Get for me the chi-squared values, guys. So the chi-squared value, please, let's evaluate and see what it gives. Okay, guys, so if you do that, guys, if you do that correctly, you should be able to find that the answer is actually 10.2. The answer for this one is 10.2. 10.2. Okay, let's take up another example and see how exactly it goes. So example 3. So we have number of calls, observed frequency, and expected frequency. So the number of telephone calls received by a switchboard of a company in 205-minute interval are shown below. Okay, so we have number of calls, and then we have the observed frequency, and then we have the expected frequency. So we have 0 here. Zero, 1, 2, 3, 4, 5. 6, 7. Okay, and the observed frequency, we have the observed frequency as 11, 44, 53, 46, 46. I hope I'm aligning them. 24, 12, 7, 3. And we have the expected. So notice that the expected value in this particular question has different values each and every time. So we have 16, 42, 52, 42, 26, 14, 6, and then 2. Okay, guys. So calculate the chi-square value of this data. Calculate the chi-square value of this particular data. So go on, guys, calculate the chi-square values. I want you guys to notice one thing as you will be evaluating. Notice that the expected value is different. So when you be evaluating 0 minus expected squared over E, this you will be using the value each and every time, a different value. If you're evaluating for this position, for 0 calls, it will be 16. For this, it will be 42. For this, it will be 52, and so on. Okay, guys, get on that and let me know what you get as your answer. Okay, guys, so if you do this correctly, then you should be able to get your answer as 3.16. You should be able to get that as your answer.